Let's get started with video number 2 tonight. Ladies and gentlemen, graphing a horizontal line and a vertical line as we continue to graph linear equations. Linear because when we graph it, we have a line. And the definition of a line is that it is straight, by the way. I don't know if I mentioned that before, but it has to be straight. So the graph of the equation y equals b is a horizontal line passing through point 0b. So what does that mean to us? That means if I'm right here on the y-axis at point 0,2, let's just pretend that's point 0,2. My equation right here says that the equation would be y equals 2. And then I would have a horizontal line going through there. So, well, we're going to prove that in a second, why we have a horizontal line. Well, our second is up. Let's do it. Here we have the graph of y equals 4. We can make our table of values, our function table of values, because this is a function. So y equals 4. Now you got to understand, it does not matter what the input is. It says y is 4. So 4 is always the output. So when I grab an input, we can grab the ones we always have used so far, is 1, 0, and -1. And when I graph that, 1 is 4, 0 is 4, and -1 is 4. And I end up with that horizontal line going through 0, 4. On the y-axis. And my equation, since b is equal to y, is y equals 4. It just makes sense. All right? Now, you might want to think, well, why is this a function? That is because the input of 1 only has one output, and that is 4. And that's okay. Ladies and gentlemen, let's go to the graph of y equals -3. So again, in our table, xy, no matter what happens, our y value is -3, no matter what our input is, and it doesn't matter. So I go 5, -3, 0, -3, -4, -3. I have a horizontal line. No matter what the input is, I have this function that is a horizontal line passing through point 0, -3. Because -3 is b, b is equal to y is equal to 3. Got it? We'll keep talking about it, so don't feel like you have to understand perfectly right now. Let's try the next one, the graph of x equal a, which is a vertical line passing through points a, 0. So this time, we're going through an x coordinate axis number, and that's a. And so let's just pretend that a is 2. Well, since x is equal to a, we have our equation of x equals 2, and we have that vertical line going through there. And we're going to prove that as we graph it, but we're going to find something interesting out about this graph of this linear equation. So if I have x and I have y, this is going to help functions become a little bit more clear to you. This is actually not a function, and I'll show you why in just a second here. Because no matter what happens, our input is always 2. It's always the same input. And so no matter what we put in, we could have anything come out. 5, 0, -1. Well, it's not a function because our input has multiple, our repeated input has multiple outputs that are not the same. So that is not a function. So we're taking a look here and graphing it at -2 and at 0. We have -2, -1. We have -2 and 5. We have this vertical line, which is not a function. However, it is a linear equation because we do have a line. It's just not a function. Moving along, with our last one here, x equals 5. So we would know we would be graphing passing through 5, 0. And so we come over here to 5, 0, and we're going to have a vertical line going right through there. Even if we make a function table, that's exactly what we're going to get. All right, so we'll keep talking about these horizontal and vertical lines moving forward because they do give some people some struggles. Let's go to our real-life application where it says the cost y in dollars for making friendship bracelets is y equals 0.5x plus 2. We're going to graph this equation. So we're going to make our function table, x and y, our function table. Our rule is 0.5x plus 2. And, well, if I don't make any bracelets, does it cost me anything? Let's find out. If I put in a 0, 0 times 0.5 is 0, plus 2 is 2. I wonder why it would cost me money if I haven't made any bracelets yet. What would that 2 represent? Well, it might represent the cost of a tool, like a pair of pliers or something, some kind of tool that is used to make these bracelets. That's what that cost could certainly be. And now we're going to think, well, I could make 2 bracelets. If I make 2 bracelets, 2 times 0.5 is 1 plus 2, that's 3. I could make 7 bracelets. 7 times 0.5 is 3.5, plus 2 is 5.5. Now, I'm not going to put a negative number in there. Think about this for a second. Why would I not put a negative number in there? What's logical in this real life application? Can I make a negative number of bracelets? No, I cannot. And so when we take a look at this graph that we need to label here so we can graph it, why do I only have quadrant 1, which is positive, positive? That is because no matter what happens, we can't go negative. We've got some limits here. There's a limit to what this graph can really do. We can have a line. We're going to talk about that too. But we got some limits. Can't have any negative bracelets. All right, and it's not going to cost negative money to make a bracelet. All right, so first thing we have is we have the cost y in dollars, so our y-axis is cost. Label that with dollars. And I'm going to go by ones on my cost. And our x-axis is the number of bracelets, so I'm going to come down here at bracelets. I'm going to make 2 at a time. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, and 22. And now I'm going to graph my ordered pair of points because this table right here sets them right up perfectly for me. So 0, 2, in other words, to buy that tool before I can make any bracelet, it cost me $2. And then it cost me 0.5, or we can say 50 cents for every bracelet I make after that. I wonder what that cost represents. Maybe the materials that are in the bracelets, like the wiring and the beads or whatever, 50 cents for those beads and wiring to make a bracelet. So I have my point at 2, 3, so I'm going to go 2 and up to 3, bingo. Make 2 bracelets, costing me $3. And then I have 7 and 5.5. I'm going to, well, my 7 is kind of right here, so I got to kind of estimate that. 7 going up to 5.5, which is approximately right there. Yep. So I'm going to put that point right there. Now I can draw my line, and it goes like this. And of course, I don't have a straight edge, so it's not a perfect line, which is really going to be unfortunate as I try to answer this question of how many bracelets can be made for $10. If I draw an accurate line because I have a straight edge, I could actually go to my $10 right here. And I could go over here, and it looks like I'm going to be doing good. Right on the line, there it is. And then when I come down, voila, 16 bracelets. How many bracelets can you make for $10? 16. I wonder if that's true. Did I draw a good line? Well, if I put in 0.5 times 16 and add 2. Well, half of 16 is 8 plus 2 is $10. Nice. So there we have it, ladies and gentlemen, our graph. Now, last thing I want you to think about on this graph. Hard to tell, but think about this. We know we can't make any negative bracelets. Can we make half a bracelet? I know you could start one and it could be half done, but is it really a bracelet until it's done? Just something to think about. Ladies and gentlemen, that's the end of this video. You have some quick writes where all you have to do on the same graph is graph y equals -1 and x equals the 5 on the same graph. You're done with your notes tonight. Always a pleasure. I'll see you tomorrow.